Hey everyone. Um, Welcome to the security section of the talk. I'm Inian. I'm head of product at Supabase. I've been with the company for more than 5 years, and here to talk about how you can build secure apps with the primitives that you get with Supabase and some of the security related features that we have released recently. How people are building business critical applications, healthcare data, and storing all of that on Supabase in a secure way. So before I go into the security section of the talk itself, like the community has been a big part of what we do at the company. You help us prioritize stuff, you help us build stuff, and you also help keep the platform secure. Since last year, we have launched a vulnerability disclosure program in HackerOne, and we've received 187 reports just this year from 131 different hackers. And that's pretty cool that people are also helping keep Supabase secure. And a big part of this is also the amount of stuff that we open source. Like what we put out in the open source is exactly what we run internally, which makes it easy to test how stuff works under the hood, which if you're a security researcher, you just love. And when it comes to principles on how we think about security at Supabase, there are two main ways we think about it. The first is that the data is yours. It's your data. You control how data flows, especially with all the new AI features that we have been launching with, like, say, the AI assistant in the dashboard, where you can query data from your database and stuff. The default is that there's no data from your database that's being shared into the assistant. And if you explicitly opt in, you can choose to share just the schema, or like you can share just the logs, or you can share the actual data in your database if you're just prototyping something and you want to get information about, like, hey, I'm trying to implement Supabase Auth and I'm getting an error, and the assistant can actually look at the logs to help you figure out what's wrong. And so, but again, if it's a production product, you may not want to do that, and that's totally fine. The second feature that is in early access right now is we are working with a few customers on bring your own cloud. So it's still the same Supabase experience, but the data is actually stored within your own cloud environment. And the advantage is that you get to, the data doesn't leave your security perimeter. You encrypt the data with the keys that you control, and that simplifies the security posture for some of our clients. And if you're actually storing healthcare data at Supabase, there is strict compliance requirements usually attached to healthcare data. And now you can mark projects that say, hey, this project has healthcare data, and we help you do the right thing by making sure that you can't disable point-in-time recovery, even if you want to, or you have MFA enforced at the org for these kind of orgs. And we make it easy for you to do the right thing. And the second principle that we have is, like, it's your data. So what's our role at Supabase in that sense? And we like to think ourselves as data custodians. You're trusting us with your data, so it's our job to make it secure. And this flows through every single decision and product decision that we take at the company. Even when you submit a support ticket, by default, the support agent cannot access the data in your database unless you explicitly give us permission to do so. And since it's your data, we also make it very easy to export the data out. Your database, your storage objects, whatever it is, you can self-host it, take it to a different provider. And that's because we think it's important to understand that it's your data and we are just the custodians of it. And when it comes to all the security features that we have built, we try to think of it in the lens of like a shared responsibility model. There are some things that we as Supabase are in charge of. We operate and secure parts of the platform. And there are some things you are responsible as the developer building on top of Supabase. And there are some things where it's a shared responsibility where you use the primitives that we provide to make your app more secure. So at Supabase, so what are the things that we handle for you? So any part of the stack that we think you as application developers shouldn't care about, stuff like how do I keep the operating system up to date? Is all the latest security patches applied? Is there a CV in a Postgres extension that's been released that I need to update the database with? Is the data encrypted at rest? Is it encrypted at transit? What cipher protocols is it using? Is our packages that we publish for our client libs, does it have attestation properly to prevent supply chain attacks? There's just like a bunch of these stuff that we obsess over daily, so that any Supabase project that you launch comes with this very good set of default encryption methods and security built in, so that you don't need to think about, hey, have I taken care of all of this? And we do our SOC 2 and HIPAA audits regularly, and every year we get absolutely no exceptions to any of our controls. And this is because this is just so ingrained in our culture that, hey, this is not our data. We are trying to protect data of our users, and that seeps into every decision that we take as a company. The other parts of security is a bit more challenging, where it comes to like how easy it is for us to secure stuff versus how much capability that we give you as developers. So it's obviously super easy to say, hey, here's a box which does nothing, and it's obviously going to be secure, but it's also useless at that point. So what we try to do is try to balance the capabilities that we give you as developers with the security of the platform. And that sometimes involves building some new stuff. So I'll give you 3 examples of this. So the first one is, this is one of my favorite features at Supabase, is where you have the metadata of all your, say, auth users or like in storage objects right within your database. And that makes it very easy to query your database to just get information like how many users signed up yesterday, for example. And we found people writing triggers and like some custom logic inside these protected schemas that we manage. But the problem happens when we want to roll out, say, there's a security update that we need to do, and we need to roll out a new version of Auth. Sometimes what happens is that the code that the user writes conflicts with our own migrations, and we are not able to roll out updates safely to users. And that obviously is not ideal, especially if it's a security issue, and we can't arbitrarily drop stuff that you wrote as well. So you need to work with the developer, and like that obviously wasn't scalable to rolling out fixes. So what we had to do was to lock down these internal schemas so that this is not possible anymore. But at the same time, we want to cater to the use cases that people had on what they were adding triggers to the internal schema, for example. So one of the things that we did to mitigate this was introduce something called auth hooks, because one of the main use cases we found people adding triggers for was they want to send an email when a user signs up, or they want to sync a different table with the information in the user schema. So now we just support this natively so that you don't need to write a trigger to do it. You can write a Postgres function or a HTTP API to run when certain actions happen in the lifecycle of an auth user. So with this, we were able to both achieve our security requirements of keeping the data schema to what we expect, and at the same time solving problems that you had with this new feature that we implemented. The second thing that we did is that the number of extensions that we had, like people always want more extensions bundled in. With Supabase, we have more than 60 extensions already. And one of the things that makes Postgres cool is the number of rich extension ecosystem that it has. But it also is a security maintenance effort for us to make sure that each one of those extensions are patched, each one has an upgrade path to say like a new Postgres version. Each one plays well with each other. So all of these things meant that anytime we had to release a new version of Postgres or a new extension version, all of this was pretty complicated for us to do. And over the last year and a half, I think, we've started moving our image builds for Postgres to use Nix. So if you haven't heard of Nix before, it's a functional package and a build system where if you give the same set of inputs, like the code, the compiler, and the dependencies, you get exactly the same output every single time. And using this, what it let us do was that it let us write automated tests much more easily. It let us build a bill of materials much more easily because we know exactly which package, which version was going in for every single image that we release. And that made audits easier, running security analysis easier, making testing easier. And that brought down the time to release a new extension, for example, from a matter of months to just days. And we still have a bunch of updates here that would make it even faster. And all of this is also open source. Like, we publish the exact way in which we build our Postgres image that runs in production. And you can check out the exact logic for it in our Postgres repo. The second way which we let users bring in more extensions without compromising security is via this framework called TLE. So TLE is Trusted Language Extensions, which is a framework or an SDK that AWS came up with. And using this, you are able to write extensions in a trusted language within Postgres. So extensions in Postgres usually have pretty wide access, like they can read and write to files. And so we need to be very careful about what extensions we bundle in. But with trusted language extensions, because of the security boundary, and we know it's a trusted language that plays well with the existing security model of Postgres, we can let users bring in their own extensions if required. And again, to make this actually usable, we built an entire package manager to bring in extensions into the Supabase ecosystem called database.build. And you can use any of the extensions built by the community or bring in extensions from that you have into your Supabase projects. And the other way we do this is with foreign data wrappers that can be built via WASM. So we have built our own foreign data wrapper framework called wrappers that you might have heard of, where you can bring in data from like Notion and a bunch of other third-party tools into your Supabase database. And if you have a tool that we didn't support, now you can just write that as a WASM module. And because for both TLE and WASM, we know what the security boundary is and we know how to reason about its security, we can let users bring in their own extensions. So again, this is an example of how we have to do some more engineering work to make sure that you are able to do what you want to do and at the same time not compromise the security of the system. The third way that we do this is this extension called Supautils. So if you haven't used Postgres before, the super user that you get by default with Postgres is pretty powerful. It can do a lot of different things. It can read and write to arbitrary files even outside the Postgres data directly, which when the first time I heard about it, I was like, sounded insane. But that's what you get with Postgres. And so but at the same time, we didn't want to say, hey, you don't get super user at all with Postgres. That would mean that you can't do the stuff that you want to do with Postgres if you don't have super user access. So with Supautils, what we did is that we started exposing all of this functionality to users in a secure way. We block the stuff that we don't want you to be doing, but at the same time, most of the functionality that you want as a super user, you still get with this extension. Again, this extension is open source. You can see how we sort of open source core parts of a security stack so that you can audit exactly what's going on inside your database. And we also recently added support for event triggers with this extension. Without that, it would have been very complicated to implement. And we are also upstreaming the support for event triggers without superuser into Postgres core so that anyone who's using Postgres, not just inside Supabase with this extension installed, can make use of event triggers. So that's hopefully gives you some idea about what we do to keep some of the things that we do to keep Supabase secure. And we also have a bunch of different primitives that you can use to build more secure apps. So one of the recent things that we launched is the support for asymmetric signing keys and API keys. So before, we have this long-lived API keys called service role key and anon key, and rotating them was always a pain because every time you have to rotate the JWT secret, it mostly means you're going to have some downtime associated with it. It was a very complex operation, which means that users didn't do that as often as they probably should be doing. And with the launch of asymmetric keys and API keys, you can do that much more easily without any downtime, and you are in much more control of how that process happens. And with asymmetric keys, also it eliminates one whole class of vulnerabilities, because all the JWTs generated by Supabase Auth is signed by a private key, which never leaves the Auth server at all. So previously, users used to do some pretty interesting stuff, let's say, with the JWT secret that we didn't want them to be doing. But now with this, you can achieve similar stuff, but you don't expose their secret outside the Supabase Auth, which improves your overall security posture. Yeah. The other thing that we have been putting quite a lot of effort on is this security advisor. This advisor has a bunch of common misconfigurations of Supabase. It's a great thing to run through before you launch your app or go to production. And we have been adding a bunch of different advisors and rules to flag common issues that we see before people go into production. And we have also been exposing these not just in our dashboard, but we also have a NCP tool that exposes the similar security warnings. So regardless of where you use Supabase from, like Figma or like Vercel V0, Lovable, whatever, you still get these warnings exposed to you, so that the AI agent can, make reasonable decisions on what to fix when it comes to security of Supabase. The other things that we have launched recently and made it more self-serve is this project permissions. So with security, you obviously want the principle of least privilege to be adhered to as much as possible. So previously, org members could only have permissions associated with all projects. So if you have like a production project and a prototyping project, a developer used to have the same permissions for both. But with this feature that is on the Teams plan, you can assign certain roles to certain projects, to certain developers, and that makes it easier to have like a stronger security posture. You can also enforce MFA across all the members of your org. We are also launching secure peering in private alpha with a few customers. So reach out to us if you are interested in this. But basically what this means is that your Supabase database, if you're only using it from, say, a few backend servers that you have and you're not using it on the client side, you can expose Supabase only to those backend servers, and you don't need to expose it to any other IP outside that. And finally, the code that you write with Supabase, like there are all these lints and primitives to help you write secure code, but ultimately, if you decide to use an insecure NPM package in your edge function, it still means that you are insecure. So this part of the stack, the application code, the edge functions code, the SQL part is still your responsibility to make sure it's fully secure. And yeah, that in terms of what's coming, so that's some of the stuff that we have already launched. We are working on more granular permissions, so you can give a developer access to, say, just the edge functions, but not the database. And this one is one I'm pretty excited by, is just-in-time database access. So we have built a custom authentication module for Postgres, which we just open sourced, but this lets you give just-in-time access to the database without sharing like your long-lived Postgres password directly to your developers. And we are also, as we release more features, we understand that it adds to the surface area of the product. We want you to be more in control and say, if you just want to use Supabase as a database, you can basically go in and turn off all the features that you don't use at Supabase. So that's something that's coming. We are working on allowing you to drain audit logs to your internal scene so that you can set up and monitor alerts based on that. We're working on ISO 27001 and scoped personal access tokens so that you can limit what resources access token that you generate has access to. Cool. Yeah, if you want to learn more about what primitives that we have for you to build secure apps, this is a link to our docs, or come find me. I'll be hanging around here. Thanks.